Everybody, this is Larry. This is me trying to do the Biweekly Contest 154 as a virtual contest. I missed it this morning. I just slept, right? I'm on this page because the main page kind of spoils the problem for you a little bit, the problem title. So I'm just here. I'm going to click on this button and then click on start very soon. So yeah, hit the like button, the subscribe button, join me in Discord. Let me know what you think about this contest and everything in between, and the videos and explanation and stuff like that. Yeah. Am I ready? Yeah, let's go. I mean, I don't know. I've been kind of not ready for a little bit of a while, so hopefully I just kind of I just get going. Let's go. 5, 4, 3, 2, 1. In case you're wondering, I'm looking at my notebook just to make sure it's still there. But let's go. Go. Where are the palms? Oh, why are they over there? Okay. Double checking that I clicked on record. Okay. Index I replace. Okay. Any number of times, min number of times. Index I replace num sub I with num sub I minus 1. Okay, so just subtract 1. That's, I don't know why to read it. Make the sum of the array divisible by k, right? Okay, so that's just sum of nums divided by mod k, right? Is that just it? Was it really 405? Yep. They could have been negative numbers and stuff. I should have double checked because it might have saved me 10 seconds, but that could have gone really poorly. All right, let's go. Q2. Okay, so nums rebel permutation array. XOR triplet is XOR of 3 elements. Okay. Return the number of unique XOR values from all possible IJK. What does this mean? Number of unique triplets. What does this mean? It's a permutation. What does permutation mean? I mean, the order doesn't matter, right? So I guess, or like even the input doesn't really matter, does it? No, I guess it could. How do you get to, okay, well. Well, no, the order doesn't matter. Okay, so that's 1. So you have just 0 to n. And then it's all the unique XOR values. So you have, in here you have 1, 2, which, so all the unique values of 3 of them, right? So, okay. So that means for one element is, well, has to, oh no, it could include itself. So, okay, so at the very least, all the numbers. So then it's just whether you can hit 0 or not. No, you can also hit bigger numbers, right? So that's not quite true. It's just that this is a little bit awkward of an example, right? So, okay. 1, 2 gives you just 1 and 2. 1, 2, 3 gives you 1, 2, and 3 for sure, and then a 0. Anything bigger than, so that means anything bigger than 3 includes 0. So then 4, what does that do? 1, 2, 3, and 4. It gives you up to 7, right? Trying to think. What is the pattern here? Am I slow? I mean, maybe. There's a 4-pointer. Okay, we know that it's at least n. Maybe. Yeah, no, it's at least n. Does the order matter? I don't think so. Because you could always do itself with itself. So all the numbers from 1 to n is possible. So it's just about the biggest number. And if it's 4, then it's but what if you add a 5? 5 doesn't give an extra bit, so Okay, it's kind of it's more easier than that, I think. It's that you take every number before. Do you? No. Wow, I am struggling today. I feel like this is like one of those silly pattern problems that I just, today's not the day. So, okay, up to 4 is going to be 7, 5, what's 5? I guess, okay, let's brute force this, right? I mean, you're not doing anything else, Larry. Oops. Okay, so this is obviously too slow, but 2 and 4, okay. And then now we want okay, let's just say 4, and that should be 7, right? Or 8? No, that, okay, that was just 0, 1, 2, 3. Okay, so that was 8 because it's 7. Okay. About 5. Okay. Is it just powers of 2? I mean, I thought it was, but I just couldn't prove it. So then now would be to 8. Wait, oh no, I wrote 18. Okay, I mean, I guess that is that. It's okay. So if n is equal to 1, then you just have 1. Yeah. Otherwise, then you return then the next power of 2 or something, right? So if n is 3, then you return 4. Why am I so slow on this? Okay. And then just return something like that. Okay, am I good? YOLO. Okay. Okay. A little bit sketchy on that one. Oh, there's a harder one. Oh, this is well, maybe it's not harder, but well, it's different anyway. Okay, still a lot of people got this, even I'm speaking into the future, maybe. Let's see. So all the numbers are still possible by themselves. 1,000. 2 to the 10, 2 to the 20, or 2 to the 11. What's 2 to the 11? Where's my calculator? 2048. I actually knew that. I don't know why. So those are all the possible numbers. But of course, if you do it in a naive way, it's going to be that cube, which is too slow, right? So guys, so does the order matter? Actually, I don't think so, but no, I guess that's fine, right? I see. Yeah, because it is bound by 2048. It's not the multiplier. Okay, so it's just yeah, a previous zero set of nums, right? Did it have to be unique? I guess it doesn't matter. For x in nums, then next is equal to for p in previous, then next dot add, and then we just do it again, right? And then just yeah. That's it. Okay. If this times out, that would be very sad. Oh, that's actually surprising. Does the order matter? Maybe the order does matter. Why? Okay, so that's less sad, but let me try to rewrite this a little bit. How do I thought the order didn't matter, but oh, I mean, I think that's okay. We just do a index something like that, whatever. What is current? Current is the current XOR, and used is the number used. Okay. Let's see. Oh, it has to be unique. Right? Yeah, this is an abuse of cache, actually. Oh no, it's not index, it's when used history. Okay, so then now you take no tick. So no tick first, why not? And then tick. That's not good. Because I forgot to call it. One time error. Oh, Okay, 248. All right, let's go. Hopefully it doesn't time out. I could rewrite this actually. Okay, fine. Silly Leetcode things. Me maybe, I don't know. 2000 times 2000. No, 1500 times 2000 of time. It's like 3 million times 3. I don't know. Okay, fine. I mean, I know how to do it, but I'm just trying to think like which way is the least likely to give me an issue. I mean, at this point, I consider it solved. It's just me being dumb, but is this faster? I don't know. I mean, it should be a little bit faster, but I don't know if it's fast enough. If it times out again, I'll just reset and then ask ChatGPT to convert it to Java. So here we go again. I'm trying to think where I could write this bottoms up easily, but I don't know. Wow, it will like this craziness for hashing, but I guess we'll see if that works. I just 248. This took longer than the Python version. This is craziness, right? The Python version was actually faster, so that does not inspire confidence. ChatGPT. I'm like wasting so much time on this because it's stupid. It's just like a branch and bound thing. Alright, this looks a little bit. This looks still the same as, I don't know. Most, I guess the Python one was memory limited, not time limited. I don't get it. I mean, is it super fast? I guess not, but it should not have been this slow. Let me double check. I mean, it should be okay. I don't get it. This is just like a... Okay, I guess I have to think about how to do it bottoms up. I kind of tried to, but that was just a waste of time. But okay, fine. Okay, I see. Fine. Right, so then here, one add num sub index, right? And then for x in 1, we do 2 dot add x to num sub index. something like that. And for x and 2, 3 dot add x. And I guess that's it. Actually, right? Okay. If this is too slow, I'll be very sad. Or memory limited, I suppose. Why is it so slow? Okay. It wasn't that bad, I guess, but definitely not practice anyway. Alright, Q4, let's go. Shortest path in a weighted tree. What is my leaderboard? That was just like a silly 20-minute penalty. A lot of people got it very quickly, apparently, so people knew what to do. Or I guess I knew what to do, I just kind of didn't optimize it away. Alright, anyway. Alright, let's go. Shortest path in a weighted tree. You're given an integer n and undirected node. Of edges. Okay, I didn't. Okay, you have a tree, undirected weighted tree. You have edges where you reweight. Queries of length q, and where queries of I is either two types of queries: update, weight, and compute the shortest path. Okay. Okay, shortest path from the root to x. From 1 to x, sorry, that's it. Of type 2 from 1 to x. I feel like I mean, this feels like one of those standard problems that I'm like, it's like whatchamacallit. What's it called? I mean, you create the shortest. Oh, it's a tree. So I mean, it's just whatchamacallit. The thing with the log n thing. And I guess you do update on that. I'm trying to think because I've never done it before, but I don't think it's that bad. Okay, let's go. Yeah, but I could see how people got it very quickly because I think it's just, well, maybe not that quickly, but it is a standard E problem. It's just I haven't done it in a while. Well, it's not that standard, but it's just like standard enough to be in textbooks, maybe. Okay. And then now we have to make sure that all the updates work, right? If you change the edge, then what happens? Is that true? How many edges do you update on that? So you do. When you do an update, what does that mean? When you do an update, you update all. I mean, that's fine. When you do an update, okay, so a couple of ways to do it, right? So first you get the longest path or shortest path or the regular path. And then when you update, it means that everything that is a subtree of that, right, we do an increment. Can I represent it as a data structure easily? Because basically you want to just go, okay, let's update it for these, like a range update almost. But we could relabel it so that we could do an Euclidean tour of the biggest node and then do a range query on the segment tree or something. Is that crazy? How many queries do we have? Yeah, we do a visit order. And then we could just do a range query. So I need a range query subtree. Or segtree, not subtree. Range queries, update segtree. Yeah, okay, I think that's fine then. Okay. Here's my lazy segtree. Right, so okay. Okay, let's see, right? So here we go in and out. Yeah, okay, let's go. It's just that first search, right? Because there's a tree, okay. Something like that, right? And that's fine. We get the reset. Yeah. Well, we don't want to set that yet. We want to say visit order, right? So visit order, that's going to be the current. So here we go, okay, mapping of node is equal to current. Right? Well, I guess it's always going to be just current plus 1, but we also have to set the parent. Okay, we'll set the parent. Okay, whatever. That's terrible, Larry. Okay, I think I got this. It may take a while, but I think I got this. We just have to set everything up together. Unless it times out, then it's just that. Okay. So then now we need. So that means that, yeah, okay. Get an edge. Okay. Okay. Maybe. Just going to keep on using maps for now. Okay, so then we start from, is it node 1 or 0? From 1, -1, 0, right? Okay, print, mapping, child out, parent. Parent's fine. Actually, I mean, this is pretty fine. Oh. I thought that looked a little bit weird. Okay, parent node. Oh, because it's one indexed. I hate you, one indexed. Okay. Okay. I mean, that's fine because this is one indexed. Child out means that. Okay. Okay. Nope, this is just confusing. This is P. Okay. Okay. So that means that one should goes from 0 to 3. Okay. Right. Okay. And then now we put everything in the segtree, right? On the distance. Do I not put distance anywhere? Okay, I don't. And I hate one indexed. Makes all my stuff confusing. Let's fix that. I think it's fixed. Okay, so then now, what am I doing again? Oh, segtree. Nope. Okay, so then now we put on the segtree. Where's my segtree? Is that the one where? This is not the one with the initializer. Okay. Okay, and then, okay, now we can enter the queries, which are of 2 types. How do people get it so quickly, other than ChatGPT, I suppose? I mean, it's not, I don't know, I feel like it's very fetchable or doable, but maybe not so quick. Just ignore for now. Else, yeah, query of x minus 1, and then Mapping of node. Really? Oh, oops. I didn't finish typing it because that's what I was confused about. Oh. Alright. I mean, it can be right just because I didn't change anything, but that's okay. I wish there's an easier way for me to compare this to that though, but it looks reasonable given no updates. Okay, so then now the magic is here. Okay, so UV, which one is the parent, right? So okay, so UV W is equal to K, right? And then okay, so if if the parent of U is V, then we want to increase everything under V. So everything including U and all its children, right? So that means that we have mapping of U and then the children out of child out of mapping of U. So we want to change that from okay, so delta is equal to, what was it previously, I suppose, which we have to do, right? Okay, yeah, fine. Okay, right. Okay, so this is the old one. And then the new one is going to be the new W, right? And then we want to segtree this. And wait. We don't want to update, we want to update with delta. Oh no, that's right, right? That is with delta. Okay, that's fine, maybe. With delta. Else. Wait, is this right? Oh yeah, this is right. Otherwise, then we do the same thing, but it is with mapping of V. Someone like this. Index out of bounds. Why? And it's going to be, this is going -1 to be inclusive. Okay, is this right? I don't think so. 7.4, we have 7.1. Why? So our query changes it from 7 to 4. Alright, there's some point there. That's good, maybe. I don't know. Negative, yeah, 74 is -3. That's fine. So then here we have mapping of 3, child out of mapping of 3. Oh, this is weird, that's why, because we want mapping of x minus 1. Right, yeah. That's weird, but I mean, maybe other things anyway, but okay, so just updates 1 from 7 distance to 4. That should be right? Okay, this one is wrong. What was it before with the update? Before the update, it is a 7. We subtract a delta from it, and it's okay. Well, something's really wrong with the segtree. I feel like everything else is right though, but my segtree template is wrong. Seems like update, it is the delta, so why? Update 1 and 1. We wanted to update from 7 to today's not my day. I mean, that's fine. We got it, but we're debugging the segment tree, which is a good sign in the sense that, you know, it means that we're close. Self.size. What does this mean? I've never usually done it before. I usually don't do recursively, so alright, let's look at the recursive version. Maybe that would be more right. Alright, there you go. 7.4. 0427 8325. Okay, so that looks good. So it was segtree. That's what I get for trying to optimize it by using iterative. Let's give a quick submit. May timeout, but I feel like otherwise everything's okay. Okay, yeah. Not too bad. A little bit slow, but I wonder if there's a clearer way of doing it other than with segtree. But I mean, because all the reason why I end up using segtree is because all the ideas that I was thinking of were very similar to segtrees anyway. But yeah. Like, because I want to do the range update, you could probably do some like tree decomposition thing. Oh, they made it so that you can click on these during the virtual contest, which is good. Because in the past I have accidentally misclicked before, but now that my contest is over, it's a little bit less useful, but that's also fine for learning purposes. But can't even load mine. But yeah, all right, I'm gonna call it a night. Thanks for watching, and yeah, yeah, stay good. Stay healthy to your mental health. I don't know what my ranking is anymore. I mean, I feel like I was a little bit slower on the Q3, but that, but only because Leetcode has like weird things and ate me 20 minutes. And was this wrong answer right? Oh yeah, the wrong answer is legit, but the other 3 just Leetcode things. And so I don't know that I take. If you want to subtract, I don't know, 15 minutes. Penalty, maybe I could have done a little bit better. I don't know what the expected thing is, but yeah, I think that's one thing. Q4 I kind of knew I wouldn't say. I mean, I think I spent most of the time just coding. Like I had the idea early, and I was gonna take my time to be deliberate, but so that's fine. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.